Hey, you guys, it's Miss All Day. It is Tuesday, April the 28th, and we're going to start chapter 13. So this is section 13.1. It can be found on pages 824 to 826. So we're going to start on page 824. So I pretty much have everything you need here. So, it's up to you whether or not you want to open your book. You don't really have to. All right, so let's get started with experimental and theoretical probability. This is probably going to be super easy for you. A quarter, when flipped, will land on either heads or tails. Heads or tails is an outcome. That means that's what's going to happen when you flip a coin. It's either going to land on heads or it's going to land on tails. That's an outcome. It's the possible result of a situation or experiment. All right. An event may be a single outcome or a group of outcomes. So you may be flipping a coin and seeing whether it lands on heads or tails, but you may be doing it like 10 times. And so that would be like an event. That's a group of outcomes. Landing on either heads or tails are both two favorable outcomes for an event of flipping a coin. The set of all possible outcomes is the sample space. So like if you did it 10 times, your sample space could be like heads, tails, tails, heads, tails, heads, heads, tails, tails, heads. That's your sample space, okay? The set of all possible outcomes, that's actually exactly what happened maybe when you flipped a coin. All right, probability is the measure of the likelihood that an event is going to come. Is that an event is going to occur, Probability is the likelihood that something's going to happen. If the outcomes in a sample space are equally likely to occur, then the probability of an event is a numerical value from 0 to 1. It measures the likelihood of an event. Now, typically with probability, like let's say you flipped a coin and the number of favorable outcomes, you were looking for how many times you got heads out of however many total times that you flipped it. Okay? All right, so you can write probability 3 different ways. You can write it as a ratio, which is probably what we'll do. You can write it as a decimal, and you can write it as a percent. All right, you see here that if it's 1/2, that's equally likely to occur or to not occur. Okay, half and half. Less likely events are less than 1/2, and more likely events are more than 1/2. If it's impossible, that would be like if you had red, yellow, green, and blue marbles, and what was the probability of you choosing a pink one? Impossible. It's not going to happen. You didn't have any pink ones. And then certain would mean every time you put your hand in the bag and pulled out something, it was going to be a marble. That's certain to happen. Okay? So that's just kind of a continuum of what could happen. Experimental probability of an event measures the likelihood that the event occurs based on the actual results of an experiment. So you're looking at the number of times the event occurs out of the total number of times that the experiment is done, like I was showing you up above. All right, calculating experimental probability. A quality control inspector samples 500 LCD, that's supposed to be LCD, sorry about that, LCD monitors and finds defects in 3 of them. What is the experimental probability that a monitor selected at random will have a defect? All right, so you do the probability and you put in parentheses what you're looking for. You're looking to see what's the probability that it has a defect. So you're going to figure out what's the number of monitors that have a defect. So I'll put with defect over the total number of monitors that you inspected. All right, so we see here that they found 3 defects. All right, so it's going to be 3. And it says that the inspector samples 500 of them. So that's 3 out of 500. When you type into your calculator, 3 divided by 500, you could use that fraction there, but we're going to turn it into a decimal and into a percent. You would get 0.006. So here's your fraction answer. Here's your decimal answer. And we're used to, when we're watching the weather, it talks about the probability or the chance of rain. So we're going to turn it into a percent. So 0. You move the decimal 2 places to the left. Okay, so 0.06%. It's a very small percentage of the ones that are defective. All right. If the company manufactures 15,420 monitors in a month, how many are likely to have a defect based on the quality inspector's results? So what you want to do, you want to take the probability of having a defect, which is 0.006. We're going to use the decimal. We're not going to use the percent. We're going to multiply by the decimal. And you're going to multiply times the total number of monitors to see about how many of them are going to be most likely to have a defect. Times 15,420. All right, so type that into your calculator and you'll get approximately 91.44. You can't really have a piece of a computer, so that's going to be approximately 91 monitors will be defective. We'll say 91 monitors are defective. All right, so the way I set up this chapter, or I'm going to try to set up this chapter, is we just did problem number 1. And so now you would go do the got it problem number 1. You can either do it on separate notebook paper or you can use the last page of these notes and you can find the problem, got it problem number 1 on page 825. So if you go to the last pages of these notes, this is the problem you want to go do now. And this will be the sheet that you can just take a picture of and just upload one sheet instead of you having to upload all the notes. All right, so let's go ahead and move on to the next concept, because you're just going to do the got it problems and turn in that one page to me. All right. When a sample space consists of real data, you can find the experimental probability. Theoretical, make sure I'm spelling it right. Oops, I'm not spelling it right. Theoretical, sorry about that. Theoretical probability describes the likelihood of an event based on mathematical reasoning. The Pearson textbook uses standard number cubes to illustrate probability. A standard number cube has 6 faces with a number from 1 to 6 on each face. No number is used twice. All right, so our second problem we're going to do, and we only have 3 to do today. Our second problem is calculating theoretical probability. So what is the probability of rolling numbers that add to 7 when rolling 2 standard cubes? Now, the first thing you would want to do is you would want to make a table. The first step, number 1, make a table. Now, I went ahead and copied and pasted the table from the book, so you didn't have to. Okay, so this is like, if you roll a 1 and you roll a 1, you would have a 1 and a 1. If you roll a 2 and you roll a 1, you would have a 2 and a 1. Okay, so that's how this works. This is what you're rolling 2 cubes, 2 die. 2 dice. 1 is called a die. 2 is called a dice. And these are what the 2 cubes. The one with red is 1 cube. The one with blue is another cube. And then that's all the sample space. This is everything that could happen. And so what they want to know is what's the probability of you rolling numbers that add up to be 7. So then you just go circle the ones that would be 7. Okay, and you see that you circled 6 of them. And you want to find out, well, what's the total number of possibilities? Well, 6 times 6 is 36, so 36. So the number of favorable outcomes, if what we were looking for, favorable outcomes, would be when two numbers added together to equal 7 over the number of total outcomes. So that's what probability is. All right, so 6 out of 36, which you always reduce it, is going to be 1/6. All right, so you would write it like this. The probability of getting a 7 when you add them up is going to be 1/6. Okay, so that's your answer for that one. All right, and then down here it says, do got it problem number 2. Do A, B, and C on separate notebook paper or use the last page of notes. This is on textbook page 826. So here's the got it problem number 2 that you could go do now. Okay, you're going to do A, B, and C. All right, I'm going to go to the third problem. But before we go to the third problem, there's a term you need to know, and it's called complement. And it's complement, C-O-M-P-L-E. And you know how whenever we were doing angles, 40 and 50 were complementary angles because they added up to be 90 degrees. This is not that kind of complement, but it's spelled the same way. The complement of an event consists of all the possible outcomes in the sample space that are not part of the event. For example, if you roll a standard number cube, the probability of rolling a number less than 3, so you're going to roll either a 1 or a 2, okay? That's 2 out of 6. The probability of rolling a number less than 3 is 2/6, but you always reduce, so that's 1/3. Now, the probability of not rolling a number less than 3, well, that's going to be 3, 4, 5, and 6. So that's 4. So that's 4 out of 6, or 2/3. The sum of the probability of an event and the probability of its complement is 1. So if you took the probability of rolling a number less than 3, which is 1/3, and the probability of not rolling a number less than 3, which is 2/3, and you add them together, you're going to get 1. Okay? So you could take 1 and you could subtract like the 1/3, and you could figure out that the probability of that event not occurring would be 1 minus 1/3, which is 2/3. All right, so we're going to use probabilities of events and their complements. A jar contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. This is problem number 3, and it's still on page 826. What is the probability that a randomly selected marble is not green? All right, so we know that we have 29 possibilities. So the probability of it not being green, we're going to do 1 minus the probability of it being green. Okay, so 1 minus, and we see that there's 8. 8 over 29. Now, you know that you could change the 1 into 29 over 29 if you want to. 29 over 29. And you would get that there are 21 out of 29 chances of you drawing a marble out of there that is not green. So we'll do this. The probability of not green equals 21 over 29. All right, pretty simple, right? All right, so you're going to do the got it problem number 3 either on separate notebook paper or use the last page. So here's the last page. Here's got it problem number 3. That's the page that you're going to put your name on it and show the work for those problems right there on the page. Or if you do it on separate notebook paper, I still need to see any work that you do. And then upload this page only. And then if you want more practice, these are optional, okay? These are some other problems you could go do to practice it. All right? All right, so we're starting chapter 13 today. We'll do 13:1 today, 13:2 tomorrow, 13:3 Thursday, half of 13:3. We'll do the other part of 13:3 on Friday, and then we'll do a mid-chapter test on Monday. All right? So you guys have a happy Tuesday. Bye.